Hello viewers on YouTube. In this video tutorial, we are going to consider how to convert decimal angles that are in degree into angle in DMS. DMS means degree, minutes, and seconds. It's a concept that is introduced to serve as an alternative way in which the decimal fractional part, that partial fraction part of angles in decimal can be expressed in degrees as well. So what am I saying next sense? Let's consider 32.85273 to be in degree. Now we can clearly see that we have some decimal fractions after the whole part. Now if we are willing to express this decimal fraction in degrees as well, or in other form, then that's when we can make use of these DMS techniques. And the question is, how does it work? And in fact, how can you solve problems involving the conversion rates? To understand this more better, let's consider some examples. So let's say we have 40.25833. And if, for instance, we are willing to convert it into DMS, what are the steps we have to go through? What you need to keep in mind is that to be in degree, the whole number of the actual problem is in degree itself. Understand? Now this decimal part is what we want to pay attention to, because that is the main focus of DMS. Is to help us to convert or to manipulate this decimal fraction part in other form. So your first step is to take this decimal fraction part 0.25833, then multiply it by 60. And that will be the first step you'll be taking in all cases. So multiplying 0.25833 by 60, I have to use my calculator for that. 25833 times 60, then I got 15.4998. Now at this point, take this whole number as well, as that will be the conversion rate in minutes. So now we have 40 degree, 15 minutes. The notation we use to represent the minute is this prime. Now the next thing is to take this next decimal fraction of the result you have, 0.4998, and again you want to multiply it by 60. So 0.4998 multiplied by 60, then I end up having 29.988. The process of multiplying by 60 will be terminated at this point. Now when you reach the point of termination, you are allowed to approximate to the nearest whole number. Since 29.988 can be rounded up to 30, then I'll select 30 as my final answer. So the measurement in seconds would be 30. So final answer in this case would be 40 degree, 15 minutes, and 30 seconds. So the notation for seconds is double prime. And this is how to easily convert decimal angles that are in degree into DMS. For easy understanding, let's consider a few more examples. On to example number 2. So consider 14.48056. Feel free to pause the video and figure this out yourself. So just like before, we said for the actual problem, the whole part of it is expected to be in degree. Now we have to take the decimal part. So taking 0.48056, and then we are expected to multiply by 60. So 0.48056 multiplied by 60 gives us 28.8336. 28 will be our corresponding measurement in minutes. Now don't go and approximate at this point, because we haven't gotten to the terminating point yet. Only approximate. when you get to the terminating point. Now, our next goal is to pay attention to this one, 0.8336. And again, we want to multiply it by 60. 336 times 60 gives us 50.016. Notice that approximating this decimal to the nearest whole number doesn't change the whole part of it. It's still 50. So finally, we have it to be in 50 seconds. So this means that our final answer is 40 degrees, 28 minutes, 50 seconds. By now, I expect you to get used to the logic and the process of the conversion rate. To understand it to full potential, let's consider one more example. So I would suggest you pause the video and try this one yourself. Then after trying it out, you can pause it and see if you have done the routine. So consider 40.6444. That's quadruple 4. So how can we convert it into angle in DMS? Well, we already have the angle in degree, and that is for 40. So 40 is in degree, then we want to pay attention to this. So taking 0.6 quadruple 4 and then multiply by 60, what gives us what? Let's see. So 0.644444 plus 44 times 60 gives us 38.3664. Then I'm going to select this as my measurement in minutes. Then after that, I'm going to take this. So I have 0.3664 multiplied by 60 again gives us what? So having 0.3664 times 60 gives me 39.984. Since I'm at the terminating process or terminating point, I can have it as 40 being approximated to the nearest whole number and have it as 40 seconds. So this means that final answer is 40 degrees, 38 minutes and 40 seconds. So this is how to easily convert decimal angles in degree into angle in DMS. Now the next thing you have to be familiar with is the reverse process. Now what if we are given the angle in DMS and then we are required to convert it into decimal angle in degrees? How can we do that? So let's look into that as well. Now for you to get this right, I would like to use the same example we used in the previous chapters. So let's use the same example and then we are just trying to reverse the process just as if we are getting the question back. Now we have the answer, we want to form the question back. So I'll be starting from this example number 3 that's still on the board and then I'll be reversing backward. So let's just assume we don't know that this angle in DMS, when it is converted to decimal, the result is this. Let's assume we don't know. So at the end of the day, we have to get this. Now sometimes you might not get the actual value in decimal due to the rounding off process. You know, sometimes you round up, while sometimes you round down. This can cause and it can alternate your answer. You understand? It can cause a change in your answer. But nonetheless, your answer must be very, very close to the actual answer. Are we together? Perfect. So now to convert DMS to decimal, the first one that is in degree, keep it as it is. Then you want to add it to the one in minutes, you want to divide it by 60. Then again, you add it to the one in seconds, you want to divide it by 3,600. And this is the process you have to be going through. Then make use of a calculator to get the final answer. So 40 plus 38 divided by 60, and again plus 40 divided by 60. Sorry, 40 divided by 3,600. Then I end up having 40.64444 repeating. So the 4s are repeated, but regardless, we can clearly see that this is actually the same as the actual problem. So that's kind of straightforward. So that's how to actually done the reverse process. So let's consider example 2. The result we got in example 2, I've actually detailed it. Let me see if I can recall. In the example 2, we got the result to be 40 degrees, 28 minutes, and 50 seconds. So let's get the question back. The question, well, don't let me write it. Let's see if we are going to get it back. So we should keep 40 as it is. Then we take 28 and divide it by 60. And then the seconds part, we are divided by 3,600. And right now, let's type that into our calculator. So we have 40 plus 28 over 60. And again, plus 50 over 3,600. And I end up having 40.48055 repeating. So the 5s are also repeating as well. So this is clearly close to the question. The question was actually 40.48056. Well, if we end up approximating, we end up having this. So that's to make sense. Now, what about the first example? For the first example, we got our corresponding value in DMS as 40 degrees, 15 minutes, and 30 seconds. So now let's convert this into decimal. So just like before, we have 40 plus 15 over 60, and again plus 30 over 3,600. And again, we have to make use of our calculator for that. So we have 40 plus 15 over 60. 40 plus 15 over 60. And again, plus 30 over 3,600. So that gives me 40.25833 repeating. Usually when it's repeating, you can put a dot on it, or you just put the dots continuously. So the question actually was 40.25833. It was not repeating, but it should clearly signifies that our answer is absolutely almost the same. So I hope you find this helpful and understandable. Thanks for watching. See you in the next video. Bye for now. So this is the exercise I have for you. Kindly convert these into DMS and try and reverse the process to confirm if you have done the right thing or if your answer is correct. Thank you once again. Bye for now.